Let's take a look at some log equations where there are logs on both sides. So I'm going to take a look in this video with you at two different examples, but they're solved the same way. So here's my first example. Log base b of 45 minus log base b of 5 equals log base b of x. Now, on the left-hand side, I have subtraction. And if you remember from the log properties, subtraction becomes division. If you need a refresher on log properties, there are videos to watch on that. So log base b of 45 divided by 5. That's the left side. I didn't touch the right side, so I'm just going to bring it down and rewrite it. Now, 45 divided by 5 is 9. So the left side is really log base b of 9. And once again, the right side is unchanged. Now, if you remember back to exponentials, if I had something like 3 to the x plus 1 is equal to 3 squared, I would be able to drop my bases and just take a look at my exponents. X plus 1 equals 2. This happens the same way with logs. Because I have logs on both sides, I can cancel them or drop them, and I'm left with just 9 equals x. In this case, there's no extra solving to be done. And once again, we have a log equation, so we always want to check our answer. The only thing I'm plugging into is x. So if x equals 9, it's positive. We're good to go. Let's take a look at one more question. Log x plus log x minus 1 equals log 3x plus 12. So I have addition. This becomes multiplication. So this is log of x times x minus 1. And then on the right side stays the same. Log of 3x plus 12. I have logs on both sides, so I can cancel them and just worry about what's on the inside. So x times x minus 1 equals 3x plus 12. And now I have a quadratic equation that I'm going to solve. We start by distributing. So x squared minus x equals 3x plus 12. Whenever you have an x squared, you want to set it equal to 0. So I'm going to subtract 3x on both sides and at the same time subtract my 12. Make sure you write it in standard form to help you when it comes time to factor. So I have x squared minus 4x minus 12 equals 0. So now I can factor. X and x. Bring down my first sign, which is a negative. A negative times a negative is a positive. Listing out my factors of 12. 1 and 12, 2 and 6, 3 and 4. Which pair gives me 4? It's going to be 6 and 2. T off. X equals 6. X equals negative 2. Remember, you always have to check. So when I check, I have lots of things to plug back into this time. So my first answer was x equals 6. When I plug that in here, I get 6. That's good. That's a positive. Here, 6 minus 1 is 5. Good. That's a positive as well. Here, 3 times 6 plus 12, I'm going to get 30. That's good. That's a positive. Let me just quickly erase those so we can check the negative 2. So if I have x equals negative 2, my 6 worked, I'm going to plug in. Negative 2, I have a negative. Cannot take the log of a negative number. So that rejects. My only answer is x equals 6. So once again, just like our first one, keep the base and switch was the other log video. That was the only different part. Everything else is quadratic. Here, same thing. Only difference is drop the logs, and then everything else is old material.